Hello guys, so today we will be solving the problem dungeon game. This is a LeetCode hard level problem, and this problem is a very beautiful combination of binary search and as well as DFS as well as dynamic programming. So let's first read the problem, and I would recommend everyone to please pause this video right now if you have not read the question, and if you have read the question you can continue further. So the problem says that there is a demon that has captured the princess and has imprisoned her in the bottom right corner of the dungeon. So we have the problem has been framed in type of story that there is a princess that has been captured over here, and then there is a man or knight over here, and he wants to rescue or free the queen that has been locked over here. So initially the knight will be having say some x health, and while moving, if the value is negative, he will be losing some health, and if it is positive he will be gaining some health. So suppose always he will be starting from 0 comma 0 index, and will have to reach at the index n minus 1 comma m minus 1, where n cross m is the size of this matrix that has been given to us. Now let's see how we can approach this problem. So we need to find out the minimum initial health that the knight might have. So yeah, we need to find out the minimum initial mini minimum health, minimum health, right? So what can be the possible values of health? We will first think, can the health be 1? Yes, the health can be 1. And also note one thing, that in the problem it is saying that if any point of time the health becomes negative, the health becomes negative, he won't be able to, if any point of time, like if you are you want to reach at point n minus 1 comma m minus 1. So if the health at n minus 1 comma m minus 1 is a negative value, the knight won't be able to reach at this location. So yes, now let's see if uh, what is the minimum possible health. Minimum possible health is 1, and what is the value of health that is given to us? Let's read the problem once again. Sorry. So basically the maximum or minimum possible value of any block in the matrix will be minus 1000 and to 1000, right? So now what will be the maximum possible, like the knight will be able to move in the right direction as well as in the downward direction. So from 0 comma 0 to n minus 1 comma m minus 1, it will take n plus m steps. It will take n plus m steps. I hope this thing is very clear to you, because the knight is only able to move in the rightward direction and in the downward direction, not moving in the upward direction and not moving in the leftward direction. So the total number of steps will always be constant, that will be equals to n plus m. So now if now understand, if what will the maximum possible health that the knight can have. So it will be into 10,000 plus some 2 or 1, anything. So can you please try to understand this step, because it is a very important point in this whole problem. Why I have written this maximum point? Suppose, let me explain you. Suppose this is minus 2. Now suppose it is only one element, like if only 1 cross 1 matrix is given to us. So if 1 cross 1 matrix is given to us, what will be the minimum possible health that will be required? So it will be 3. Why 3? Because minus 2 minus 1 and then plus 1, right? This will be the minimum possible health. Anything less than 3 is not possible, because less than 3 is 2, and minus 2 plus 2 actually is equals to 0. So what it means that if I am taking the health as 2, it will simply mean that I am not able to reach the final position, right? So what is the worst case scenario of all? Suppose the worst case scenario is that my all the blocks are 1000, minus 1000. So if my all the blocks is minus 1000, what would be the total deduction in the health of the knight? It will be n plus m into minus 1000. Can you now please understand this step, why we are actually writing this equation? because we have to move n plus m steps, and in the worst case scenario my each and every element can be minus 1000. So that will be the maximum loss in health, hence we can find using this the maximum possible health that is possible. Now if we multiply it by minus 1 and then add 1 to it, this will be the maximum possible health that is possible. So now we have a minimum health and now we have a maximum health, right? This stuff, this is the minimum health and this is the maximum health, right? Now what? Now suppose my answer lies over here, suppose my k is the answer. Now if my k is my answer, and suppose uh, forget what I just said that k is my answer, let's start from very scratch for binary search. Suppose my k using k health initially, the knight can rescue the queen. What does that mean? It means my k can be a possible answer because we need to find out the initial health of the knight in such a manner that he will be able to rescue the queen, right? So now using k, if I am able to rescue the queen, anything that is less than k can be my possible answer, but anything greater than k will obviously be my answer because I am able to rescue the queen with using k health. So using k plus 1 health, I will be obviously able to rescue the queen. But we need to check the minimum, right? We need to check the minimum. So if we will call a function and we will check using k health, k initial health, are we able to reach the final position? If we are able to reach the final position, we will simply reduce this search space because this search space will always have the answer, right? And we need to find out the minimum possible value. So the minimum possible value will lie in this search space. In this way we are actually reducing the search space, we are dividing the search space by 2, hence leading the concept of binary search, right? So now till now what we have studied, let's try to write the pseudo code of this problem. Now pseudo code will look like this. Suppose my low will be equals to 1, high will be equals to m plus n into 1000 plus 1, right? Now we will run a while loop. The standard, I hope if you had come to this problem, you might be knowing the binary search, because in this problem I am not explaining you what is binary search, how is binary search implemented. So we are finding mid here, right? And if mid comma nums, the 2D vector is equals to true, we are simply gonna store this mid into the answer vector, and then we will shrink the search space to the left half. That means high is equals to mid minus 1, else low is equals to mid plus 1, and in the end we will simply return answer. This is the binary search pseudocode. Binary search pseudocode. Yes, pseudocode. Now I hope many of you would have understood the problem till now. However, we have one very important step left. We need to define this function. I mean, how can we check that this possible, this health is possible uh, for the answer? This help is possible to be an answer. I mean to say, is the knight able to reach the final destination using this k health or not? Right. So what we will be like, if this is the, suppose this is the matrix, right? Suppose this is the matrix. Yeah. Now what? Now suppose this is the location of I comma j. This is the location of I comma j, and this will be I comma j minus 1, and this will be I minus 1 comma j. So to reach I comma j, we have two ways. What are the ways? I minus 1 comma j, I comma j minus 1. We have two ways, right? Right, yeah. So now if I am not able to reach, if I am not able to reach I minus 1, I minus 1 comma j, will I be able to reach I comma j? Think of it. Yes, I mean not sure, but we can reach using I comma j minus 1. However, if we are not able to reach I minus 1 comma j and I comma j minus 1, will we be able to reach I comma j? No, because to reach I comma j we have two paths, and if these two paths are itself negative, are will we be able to reach the further paths? No, we will not be able to reach further paths. However, if only one is negative, other is positive, we can reach the path from there. However, if both are positive, we can reach using both paths, but we need to find out the minimum. So we will take the minimum of the two paths. So I hope this whole this whole function to check whether this health is possible to be our answer is clear to you. And now I will be moving to the coding section and trying to explain you using code. Using code it will be better, it will be easy to understand for you. And in case you face any doubt, comment section is always open for you guys. Yeah, see, this is the basic standard binary search that we have implemented. This is the all this is a very standard binary search that we have implemented. It has nothing very special, it has nothing very special. Now the main special stuff lies in this OK function, and this OK function will be checking if we are able to reach in the final destination using mid initial health or not. So if my initial health is mid, the initial health is mid, so actually what we are doing is we are creating a new 2D vector, and in the 2D and in the 0 comma 0, in the position of night, I am storing nums of 0 comma 0 plus point. Why this I am doing is because it is a very basic explanation, because I am having initial points, and then at 0 comma 0 I have some nums, right? So current of 0 comma 0 will be storing the sum of those. If nums of 0 comma 0 will be having some value, suppose 2, so the final health of the night will increase. However, if it is initial health, however, if nums of 0 comma 0 is negative, the initial health will decrease. So now what we will do, we will simply fill the first row and the first column. Now here comes the concept of dynamic programming. Actually, this current vector, 2D vector, is nothing but a 2D array that is basically doing the work of dynamic programming. I hope it is clear to you. So now let's see the first function, first for loop. So first for loop runs from I to n. From first to n. Using this, right? So if I am standing at this position, how can I reach at this position? I can simply reach at this position by using the upper block, right? So from upper block, if the upper block is itself negative, I won't be able to reach at the I comma 0 block, so I will simply put -1 over there. However, if it is a positive value, we will simply use this value plus nums of I comma 0 and store it in my dp I comma 0. Actually, the curve of I comma 0 is our dp vector. Similarly, we will fill this column, this row 0, first row. And if in case my any of the if I am standing at this position, how will I be able to reach at this position? I need to check if I am able to reach at this position or not. In case this is a negative value, this is a value will be storing a -1. Why? Because I am not able to reach at its previous value. How can I reach at the 0 comma I value? In the similar fashion, if the previous value is a positive value, we can reach at this position using these equations. Now what? Now we will be having now we will run a for loop from I1 to n and -1 and j1 to m -1. So in case my both I minus, suppose I am standing at this I comma j, I will I have explained you now how can we reach at I comma j. There are two ways, I minus 1 comma j and I comma j minus 1. So I minus 1 comma j, and if my I minus 1 comma j and j I comma j minus 1 both are storing a negative values, it means there is no way to reach I comma j. So we will simply return -1, so not return, we will simply store -1 at current of I comma j, and we will continue it. However, if in case my current of I minus 1 comma j is a negative value, it simply means that current of I comma j minus 1 is something a positive value. It means at I comma j I will be able to reach at I comma j minus 1, and then we will be adding nums of I comma j. In the similar fashion we are doing this also. And if in case both are positive, we are taking the maximum of I minus 1 comma j and I comma j minus 1. and then we are adding nums of I comma j to it. And if in case my last column last block n minus 1 comma m minus 1 block is having some positive value, sorry for the notifications in between, extremely sorry for that. So what I was saying is, if my last block is a positive value, is a positive value, it simply means that my health is a possible health, and then we will simply return true from here. I hope this question was very clear to you, and this was a hard level problem. If you are not able to do it, there's no that's not a very big issue. I myself took a bit of hint from some solutions and editorials. So basically this problem is a great question to learn dynamic programming, binary search, DFS. Like you will be asking how DFS. I mean, by how I define DFS is, you actually go in depth, right? So how are we going in depth in this problem? See, in this problem, how are we going in depth is, suppose I am standing at I comma j, at how many position, by how many positions can I reach I comma j. So basically, if I am at I comma j, I can go to I plus 1 comma j, and then I will be going into depth, and then depth, and then depth. So that will be a depth first search, not specifically search, but like it is some sort of depth, going in depth, right? So not actually DFS, but yeah, some sort of DFS, that intuition comes in. Yeah. So also DP has been used, binary search has been used, and if in case if you have any doubt, please ask me in the comment section. I'll be very glad to help you. Actually, this is my new channel, and please support me by subscribing my channel. I will be uploading the continuous LeetCode and Geeks for Geeks problems based on data structures and algorithm. And in near future, I am trying to upload. I'll be trying to upload new videos on machine learning also. So yeah, please subscribe my channel and do hit the bell icon and like my video. Thank you.